So 6-4 is rectangles, rhombuses, and squares. And we're going to talk about a bunch of different properties that go along with these things. The good news is rectangles and rhombuses, when put together, make a square. So whatever's true of a rectangle is also true of a rhombus, and whatever's true of rectangle is also true of a square, and whatever's true of a rhombus is also true of a square. So it sounds like we're doing a lot. It's not terrible. So we're going to just define, first of all, these three things so that you know which one is which when we're looking at them or talking about them. So first one is a rhombus. Can anyone tell me what a rhombus is? Sometimes it looks, diamond shaped. What is true of its sides or its angles? Do you know anything? It is a parallelogram. Yep. So everything we talk about today is going to be a parallelogram. So it's a parallelogram with what's true of its sides. Do you know? They're all the same, okay? So it's a parallelogram with 4 congruent sides, which means it can look like a lot of different things, but one option would be if all 4 of these are the same, and it is a parallelogram, okay, that would be a rhombus. So a lot of times I feel like it looks like it's kind of on a little tilt. Doesn't have to be, okay? A rhombus could also look like this, okay? It just has to have 4 congruent sides, and your opposite sides have to be parallel. So that's a rhombus. Can anyone tell me what a rectangle is? It's what? An elongated square. It doesn't have to be an elongated square, but it can be an elongated square. It's still a parallelogram, okay? So it's a parallelogram. And the definition of a rectangle, where a rhombus was 4 congruent sides, a rectangle focuses on the angles instead. What's true of the angles in a rectangle? 4 what? 4 right angles. Okay, so it's it is a parallelogram with 4 right angles. Okay, so this one's dealing more with angles, so it might look like this, right? Parallelogram, where we know those are all right angles, but it could also look, oops, that was terrible. It could also look like this, where it looks more like a square, because a square is a rectangle, okay? So as long as it has 4 right angles, it is a rectangle, and it's a parallelogram. Okay, so I'm going to give you a couple pictures, and just knowing what the definitions are of these things, actually, I'm going to give you square too while we're at it. Let's do that first. Last one is square. So based on the 2 definitions I gave you there and what I told you earlier, that rectangles and rhombuses put together make a square, any idea what the definition of a square might be? Right, it is a parallelogram with 4 congruent sides and 4 right angles. Okay, so I'm going to give you pictures. You tell me what you think this figure is. Okay, a rectangle, a rhombus, a square. What's the most specific name you can give it? Will you just put it on my document camera? Thank you. Okay, so is this a rectangle, a rhombus, or a square? If I tell you that, So it is a parallelogram, and I give you one right angle. Why would it be a square?
Because the sides are.
We don't know the sides are congruent, though, right? We know the sides are parallel. You okay?
Yeah.
We know the sides are parallel. Opposite sides are parallel. Did I see a hand somewhere else? Yeah. Why would it be a rhombus? What's the definition of a rhombus? For what? Congruent sides. Do we know anything about the sides' length? We don't, right? So even though it looks like the sides are congruent, we don't know that, so you can't assume it. What do we know? We know there's a right angle. Okay, now think about this. If it's a parallelogram, which it is, and there's a right angle, what's the measure of this angle down here? 90 degrees, right? Because those would be same side interiors that have to add up to 180. Then you could wrap around this side. These would have to add up to 180 also, and these would have to add up to 180 also. Or you can say opposite angles are congruent in a parallelogram, right? So we actually, even though they only gave us one angle, we know all four of them. So what is that figure? It's a rectangle, right? We know that we have four right angles, and we know we have a parallelogram. We don't know anything about the sides. So because of the four right angles, we know it's a rectangle. Okay? I'll take it right here. Thank you. Okay, what would this one be? Don't go based on my drawing. My drawings are not awesome. All right, so this is what we know. First of all, is it a parallelogram? Yes, right? Because opposite sides are marked parallel. Okay, so we know it's a parallelogram. So look at its sides. Is it a rhombus? Does it have four congruent sides? Think about your properties of parallelograms. What do you know about opposite sides in a parallelogram? They're congruent, right? So if this is a parallelogram, which we already said it is, then this side on the right has to match up with the side on the left, and the side on the bottom has to match up with the side on top. So technically, even though they only gave us two, we know all four are congruent, okay? How about the angles? They're all 90 because opposites are congruent, right? So we know that's 90 and 90. And since it's a parallelogram, we know consecutives are supplementary. So this would be 90, making this one 90 as well. So even though it only marked for us one angle and two sides, we actually know all congruent sides and all congruent angles, which makes this a what? A square. Okay. Because you have four congruent sides. Oops. My brain is not working today. And four right angles. Okay. Questions on that? All right, so just keep in mind that if something is a square, it's going to be a rhombus. If something is a square, it's going to be a rectangle. That doesn't mean if it's a rhombus that it has to be a square, right? A square has to be a rhombus. A rhombus does not have to be a square. Does that make sense? Okay. All right, I have two theorems for you about rhombuses that you're going to use quite a bit today. The first one says the diagonals of a rhombus are perpendicular. Okay, and I think it's easiest if you actually start with the diagonals rather than starting with drawing a rhombus on this stuff. So if I want to make it a rhombus, If I draw perpendicular diagonals first, you can kind of get a better idea. So if this is a rhombus, right, all four of these are congruent. It says the diagonals are perpendicular, and that will always be true of a rhombus. So if you draw your two diagonals in, they're always going to form a 90-degree angle. Okay, the diagonals of a rhombus are perpendicular. The other theorem that goes along with rhombuses says the diagonals of a rhombus bisect. What is bisect? Cut in half. Bisect a pair of opposite angles. Okay, so a rhombus is a parallelogram, right? And we know that opposite angles in a parallelogram are congruent. So I'm going to draw you another rhombus here. Hopefully this one's a little better than my last. If we draw the diagonals in, what we're saying is because we knew, actually let's just rewind. I know this right now, right? I know if this is a parallelogram, which I'm telling you it's a parallelogram, I know that this angle is the same as this angle, and I know that this angle is the same as that angle, right? Okay, well now if we draw the diagonals in, this theorem says that that diagonal cuts those angles in half. So what happens is now we have four congruent angles on that diagonal, and we have four congruent angles on this diagonal. So as long as these were all the same length, as long as it's a rhombus, then you have four angles that are the same, four other angles that are also the same. Okay? So the diagonals of a rhombus will bisect a pair of angles. Any questions on that? Okay, so I'm going to give you a couple examples of how you're going to see this today. So this is example 2. Let's say this is a rhombus. Rhombuses are... There's a diagonal. This angle is 100, this angle is 1, 2, and 3. Can anyone tell me the measure of angle 1? It's 100, right? Why do we know that's 100? What's the property? Opposite angles are congruent, right? Opposite angles in a parallelogram are congruent. And I'm telling you right now, this is a parallelogram. I should have said that, sorry. So if that's a parallelogram, opposite angles are going to be the same. So that means angle 1 here is 100 degrees. Okay. What kind of parallelogram is this? Based on the markings? If you have 4 congruent sides, it's a what? It's a rhombus, okay? So in a rhombus, the diagonals did 2 things. What was one of them? What's the one that maybe looks like it applies here? What does it do to opposite angles? Bisects them, right? So if it's bisecting those opposite angles right now, here's what we know. We know all 4 of these are the same. We just have to figure out what is that number. How can you find it? Do you see anything there? How about think of just half of that figure? Yeah. So you're looking at a triangle. What kind of triangle is that? If we just ignore this whole side of the triangle, right? What kind of triangle is that top triangle? It's isosceles, right? If you have 2 congruent sides, you have an isosceles triangle. So what you're going to do is take 180 minus 100 leaves you with 80 degrees, okay? That 80 has to get split evenly between our two base angles. So you're just going to cut that 80 in half, and you get 40. That means every one of these angles, 40 and 40, 40 and 40, would be 40 degrees, okay? So angle 1 is 100, angle 2 is 40, angle 3 is 40. Questions on that? So just keep in mind diagonals bisect, okay? They cut the angles into two equal parts. Okay, how about this one? If I give you a rhombus with the diagonals drawn in, and again, this is a parallelogram, okay, so it is a rhombus. If I give you one angle, this one up here is 50, and then I want to know angle 1, angle 2, angle 3, and angle 4. What was that first theorem we talked about with rhombuses? Diagonals are what? Perpendicular. So what does that tell us in this picture? The diagonals are perpendicular. What angle do we know? Yeah, Jared. Right. Okay. So here's where you have to be careful. This rule applies in a rhombus. It does not apply. It does not apply. I cannot speak today, you guys. In a parallelogram in general, right? So today this is an easy rule, but in the next couple days it gets a little harder because you'll see parallelograms that aren't rhombuses and you'll want to make the diagonals 90 degrees. So just keep that in mind. They're only 90 in a rhombus, okay? So here, angle 1 is 90 degrees. That means every one of these is 90 degrees, okay? So angle 1 is 90. What else do you know? What's the other thing diagonals do? They bisect. So what angles do you know? Two and 3 are both what? 50, right. So if I know that this is 50, then so is this one, so is this one, and so is that one. So angle 2 and angle 3 are both 50. Or you could have done alternate interior angles with that if you forget the rule, because 50 and 2 are alternate interiors, right? And then how do you find 4? Right, we know 2 is 50, right? So 90 plus 50 plus the measure of angle 4, bless you. That would have to add up to 180. So if we take that away, then the measure of angle 4 is 40 degrees. Okay, questions on that? Okay, so those are the two theorems that you're going to be applying to rhombuses. Okay, then we're going to talk for a second about rectangles and do one problem with that, and then we're done. Okay, new theorem. This one's with rectangles. This one says the diagonals of a rectangle are congruent. Okay, so if I have a rectangle and I draw the two diagonals in, that's too far. Okay, right now I know that AC is congruent to BD, okay, because the diagonals of a rectangle will always be the same. So we know they're congruent. So if I give you a problem like this, and say find the length of GE and FD. Okay. If GE is 6y minus 5 and FD is 2y plus 4. Okay, right now you don't technically even need a picture of this if they had told you those were diagonals of a rectangle, right? Technically in the wording it doesn't say right now that they're the diagonals of a rectangle, so I will draw you a picture just so you see it. But because we know diagonals of a rectangle are congruent, if you know those are diagonals, you don't need a picture to work from. So let's say we have this F, E, D, G, and we'll call this H. Do you remember back to 6.2, I want to say, maybe 6.1. What do the diagonals of a parallelogram do to each other? Just a regular old parallelogram, nothing fancy about it. Not a rhombus, not a rectangle, just any parallelogram. The diagonals do what? They intersect, and what is that intersection point? It's going to be the midpoint, right? They bisect each other. So right now, I know that FD is congruent to GE, but I also know that these are the same, and I know that these are the same, which makes all four of them the same in a rectangle, right? Because they bisect each other, but they're also congruent to each other. So that means all four of those are actually the same, okay? That doesn't really apply to this problem, but you'll see it down the road. Okay, so I know GE is this. I know FD is that. What do I do with them? Just set them equal. We know the diagonals are congruent, so we're going to say 6y minus 5 equals 2y plus 4, and then just solve that. So take away the 2y, you get 4y on the left, add the 5, you get 9. So then you're just going to divide by 4, which is not a pretty number. So you could say y is 9/4, or if you want to turn that into a mixed number, that would be 2 1/4. Either way is fine. I think it's easier to just leave it as 9/4 for the sake of plugging it into your problem. So y is 9/4. I want to know the length of each line. So you're just going to plug that in. So you would say for GE, it's 6 times 9/4 minus 5. Do you remember how to do that? 6 times 9/4? Multiply across, divide by 4, right? Does that come out to a nice number? So 9 times 6 is 54 divided by 4. We'll just call that 13.5 for now. And then you would just subtract the 5. So GE would be 8.5. What is FD going to be as a length? Should be the same, right? So you should get that FD is 8.5, but just to make sure that you did it right, you can always plug it in to make sure. So 2 times 9/4 plus 4 is 18/4. 18 divided by 4 is 4.5 plus 4 is 8.5. Okay, so you do get the same length for both of them, which is a good way to just verify that you did it right. Okay, here's my question then. Look at that picture. What is this? It is an isosceles triangle, right? How many congruent isosceles triangles are there to that triangle? 1, right? Because we know opposite sides are congruent, so we know those are congruent. So these two triangles here are the same, right? And they're both isosceles. How about the other two? They're the same, okay? Not the same as the first two, but these two would also have to be the same triangle, and both isosceles. So just remember that. As you see an isosceles triangle, what do you know about isosceles triangles? They have two congruent base angles, right? So these two angles are the same, which makes these angles the same. Or these two are the same, which makes these two the same. So there's a lot of angles that you can find in a rectangle with the diagonals drawn in if you have very little information. You can find a whole lot of things, okay? Any questions on that? All right.